This test is for the peripheral power supply, and basically what I'm doing is making sure that everything is well within its range, that nothing's overheating in the process of actually supplying power. The test actually was written so that I would have a load on this, resistive load, but because I couldn't find the correct resistance for this, I decided to actually hook up the load that we're going to be supplying. So basically I'm supplying the entire project right now, the power to all the projects, to simulate resistive load. But anyways, basically we have the power connected to the transformer, which is also the frequency sensor transformer and the contact driver. And what we're doing here is going through and taking a look. So I have it set up right now. This is the actual voltage, which is displayed. It's 17.5 volts after rectification. The AC wave that's coming in, I can also scope. So we have 15.3 volts RMS. We have a little bit of distortion right now due to switching noises, but that's everything on its own works, but as a system, for some reason we have a lot of distortion. Anyways, going on, coming out of the power supply now, we have 11.4 volts on the scope. Actually, my multimeter reads it more closer to 12, but either way, the Arduino that's going to be powered by that 11.4 source needs between 8 and 12 volts, so we're well within its range there. And also one of the other requirements I wanted to test is to make sure that I was staying below the 800 milliamps is what I said that was the most. So coming out of that, I actually have a current thing set up is 106.5 milliamps, which is going to be the most that we're going to supply at any one time, especially with the black light lit that much. So we're well within our current ranges, and this thing, the voltage regulator, it's just a IC switching regulator. It can take up to 60 volts in, and so our 17.5 volts is well within the range there too. And then the last thing I wanted to check real quick here is we also have a 5 volt power rail for other purposes. So I'll hook that up, especially the frequency sensor that's set up right there. And oops, what did I lose here? Okay, sorry, just when my connections came loose. It's running 4.2 volts, and just to double check the milliamps didn't change. It went up by about 10 milliamps, so still well under 800 milliamps, and within our range up here. So that should conclude everything that I needed for the power supply test.